Welcome everyone to the fifth KZG-Ceremony call. So I think most people know why we're here, but I see JB and Alex. If you're new, this is the call to coordinate around the KZG-Ceremony, which will build the foundation for proto-dank sharding, which is an upgrade we hope to put into progress after the merge. It'll be the next upgrade, help some scalability. Let's see. So top of mind is the audit. I guess we could start with that. Carl and Kev, do you want to just talk about where we're at with that? Well, I guess the audit is going to happen in a couple weeks, or that's when it's slated to kick off. There's some work that still needs to be done, and maybe we should just go over that before getting into other stuff. If Carl or Kev want to just give an overview of what's left before that starts.
I think Kev can best speak to sort of where his repo is in terms of spec alignment. Yeah.
Yeah. So I was reading the specs again. I think there are some changes that I need to upstream to the spec. I basically created a new Python implementation that to get some executable specs, and I was going to send it to Carl and then basically modify the Rust code again based on that. So yeah, that's where I'm currently at.
So you have now sort of a further repo that you want upstream?
Yeah, just I should be able to push it by the end of this call. Just give me 1 second.
Okay, fantastic. Yeah, I will review that ASAP because I guess getting all these final changes in there and then merged into your Rust stuff would be, well, is #1 priority for the audit.
Mm-hmm. I don't know if we want to discuss those changes now or after.
Yeah, I think that's fine. This is no time like the present.
We can discuss it now.
Yeah, I don't see why not.
Right. So one change that Carl, I don't know if you're strongly for it, is to have the cryptography library only deal with one ceremony. So the context of having multiple ceremonies is sort of done by the client, the front end.
So I guess this comes down to like complexity on the higher levels of abstraction. So I guess more for Jeff or other people implementing it. It certainly simplifies the cryptography a little bit, but also like I don't think majorly so. So I don't have strong opinions either way. Like we're just shuffling around complexity.
Right.
I guess the only aspect of this I do like is the idea of just not having to sort of touch the files. Like we just pass in the structure that is exactly as it is from the interpreted JSON.
Right.
In terms of simplifying things, but yeah, otherwise it sort of gets touched in two places. Once when we deal with it on the website side, and then again once it gets passed into the crypto library.
Right. Okay, so I'll just defer that to Jeff to see the complexity. I guess also the JSON as well. For the crypto, I noticed that we're dealing with JSON. Currently in the Rust library, we basically just serialize the points in the binary file. So it's just like 2 to the 15 G1 points followed by 65 G2 points. But in the specs, it's a JSON file. I noticed the rationale was so that we can basically, I think it said something about touching parts of the transcript. Is that correct?
Yeah, so I mean, look, my fear here is, like you say, you just encode the points, but like under what encoding?
Usually there's like for points you can do like compressed form to just send it over. Like they usually have a canonical serialization.
Okay, but then like, how do we pack this serialization into a binary format?
It's just one after the other. So if it's 2 to the 16 points that you need, you just do like 2 to the 16 G1 points followed by 65 like G2 points, for example.
I mean, we can do that. I think I'd prefer to stick with something that has a little bit of structure. Like this is what I'm appreciating about the JSON. So like the JSON is just basically a string which contains the hex encoded version of those the compressed form of the points.
Right. The benefits of the JSON was
yeah, so primarily just like it's like a complexity thing. I mean, I agree that it seems relatively trivial that like we just pack them back to back, but like there's like now I'm worried about like starting to worry about like what exactly the byte encoding looks like. Like
right. I thought it would just be the same as the JSON. It's just that instead of the hex strings, they're just basically concatenated together.
I mean, in essence, it is. But I'm certainly not going to die on this hill. I don't think it's super important, but I do think it is like sort of simpler to like, particularly for someone if they're trying to implement sort of the just the website of this and not the crypto. So sort of up to the SDK, then it's easier to think about like this. And I worry a little bit like about what like worrying about now byte encoding in byte arrays in what's it called in JavaScript, etc., etc. Like if we were writing this all in low-level languages and like we didn't have this file to pass around or whatever, then absolutely I'd agree with you. But sort of given this level of abstraction, I think it's much easier just to see and understand what the file means.
I don't know, what does everyone else think about this? I guess the main thing that popped up for me was that the JSON on the cryptography level seemed a bit off, which is why I brought it up.
Yeah, I tend to think there's less ambiguity with the JSON encoding. So I'd lean slightly in that direction.
Okay, cool. JSON.
So is your particular complaint from the like what the SDK looks like, or just the idea of these JSON encoded bytes in the first place?
Yeah, it seems that we don't ever need to actually look at what the points are doing. It's just really a really flat serialization on the cryptography side, which is why I brought it up. Like I imagine the front end would need some, like it makes sense on the front end for me, but then for the cryptography part, it seems that we just need the bytes and we just need to know how many points there were.
Yeah, I agree. But like, again, these are also sort of standards that seem to exist across the Ethereum space. If you go like right down to like how the EL and CL talk to one another, or how the Beacon nodes and VCs talk to one another, all of this stuff seems to be just via basic JSON, even if they're like way more efficient or more sensical ways of encoding this. It's all just hex strings for ease of use. And I think this is an extension of that.
Right. Did anyone else have any thoughts? Dankred or JB? I don't think so.
So, I mean, I guess one further thing here is that with the definition of the SDK, what you'll be passed in is an array of strings, basically, as opposed to the JSON itself. So it's sort of string to bytes, and then just from there. So you're not like, you don't need a JSON library or whatever in the cryptography. It's just standard string manipulation. And there shouldn't really be manipulation beyond just iterating over whatever you passed in.
Wait, so the JSON is only on the client, the front end side?
I mean, yeah, in essence, this is again why I was trying to have the what I was meaning when I was messaging the other day about exactly how would you like this interface to be encoded for the SDK. Because now the SDK defines all the same, like the same types, but they're defined now as native JavaScript objects as opposed to JSON.
Right. Okay, yeah, I think I can live with, just gonna put keep JSON, yeah, strings. So I need to change that. Okay, yeah, I mean, it doesn't change much. I think if the cryptography never needs to worry about the actual JSON file,
Yeah,
it should be fine.
yeah.
I think I'll write this down. Oh, sorry, didn't mean to send that. I'll write this down as one of the part of the rationale, because I think in other ceremonies they usually do this packed
Absolutely.
byte encoding.
Yeah. And I think that the two differences here is, one, I'm very heavily trying to optimize for anyone to be able to write their own software, and B, that we just have so few points that like the amount saved over writing your own byte encoding or deciding that is just not worth it.
Right. So the main reason is for readability.
Yeah, like readability, like insight into what's actually happening.
Right.
Happening where.
And because in Ethereum, it's this is what you usually do.
Yeah, this just seems to be the standard that we use everywhere.
Okay, okay, that's cool. Looking at the notes, another thing was the actual encoding. I was using PyECC and they basically always compressed the point, but I noted that we could just use the uncompressed point. I think with the JSON idea, we might not be able, we could do it, but it's going to make the file a lot bigger. The idea was that with the uncompressed point, when the contributor gets the points, he no longer needs to decompress the points, which I think is a square root per point.
Yeah.
But I guess this is fine.
I mean, I personally think so. Yeah, I think we should just run with
what is
that.
What is the trade-off here between like that's more bandwidth at the cost of lower performance, right?
Yeah, basically.
Sorry, at the cost of higher performance.
Yeah.
Can we quickly go through what that means? What is how much bandwidth do we need to transfer the full?
So the ceremony right now, the file's like 7 megabytes. Going for uncompressed would push this up to like 15 or so megabytes.
I see.
So it's an effective doubling, and it's as
And
Kes says, basically
what is the decompression time? Do we have any stats on that? How long it
no,
takes to
but
decom?
small relative to, I think, to the other stuff we're doing.
Right.
I think it's an
Isn't it?
inversion. It's a square. I think it's an inversion per point. So about 2 to the 16 inversions, I guess.
Wait, but inversions can be amortized. Inversions are basically just multiplications.
That's true. So is it fine? Right, yeah, maybe we can just, yeah.
I mean, it feels to me like the better trade-off is actually to keep it compressed, because 7 to 15 megabytes, that does feel significant. And you're saying the other side, the decompression time is not significant compared to other stuff we're doing.
I don't know if it's not significant, but if you can amortize it, then I'd say keeping it compressed would be better.
Like, what's the worst case connection that we are factoring in? Like, let's say it's 1 megabit. Then 7 extra megabytes is like a minute or something. Bit more.
Is that to download?
Well, or up, I don't know. I mean, both sides, right? We
Okay.
also, like, I mean, isn't it the same for sending it then?
I mean,
I can easily imagine people even using slower connections than that. Like, I mean, especially when you consider that upstream is often much slower than downstream.
I mean, I kind of hope we can be a bit faster than that.
Right.
But I mean, if we're using those kinds of numbers, then like absolutely we should stick with a compressed form.
Yeah.
Okay, but I mean, let's say, like, what is the internet connection where they would be equal? I mean, how long does it take to decompress? Let's say it's I don't know, 100 milliseconds or 1 second.
It's much. I mean, it's much less than 1 second. The whole ceremony, I think we have down in like 3 seconds in a fast enough implementation.
Right.
Like written in Go. That
Right.
includes all the decoding or whatever.
Well, but not in WASM, right?
Not in WASM.
In WASM,
Yeah.
it's like 10x slower.
Not quite that bad, but yeah, something like
Okay.
that. 5 to 10x. Yeah.
Okay. I mean, my intuition is that compressed is better, because the worst case, like, I mean, the worst case connection is just much worse than the worst case. Like, so I guess, like, in the average case, it doesn't matter much. Like, both are pretty fast, and like we're both talking about fractions of a second.
Mhm.
But if either, like, basically you're unlikely to get 100x slower processor, but you're quite likely to get 100x slower internet connection.
Right. Okay. Yeah, I think that's
Like,
fair.
someone might be
Yeah.
doing over 3G or whatever. So I feel like I
Right.
mean, compressed seems the right trade-off to me. By the way, are we sending them as JSON or are they like binary?
It's Json.
JSON.
So that's another, I mean, that's another factor of 2 or something, right?
Yeah, that's how we had these 7 meg file sizes.
Yeah. I mean, so you could probably get another factor of 2 if you can compress that. Like, send them as gzip or something.
Right.
Yeah.
We just went over the JSON discussion. I don't know if you was not here. Did you have any opinions on that? Basically, JSON versus binary.
Right. I mean, like, it does feel like it makes a significant difference, but I guess, like, JSON will be potentially much easier to code and debug. So maybe just compress the JSON. That should give you pretty much the same. Because
mean,
the problem is that numbers are stored as hexadecimal, right?
Yeah.
So, and that should be very well compressible. Like they should
Well,
just,
we don't really have any numbers, right? It's only points.
right. And how are they stored?
They're strings, hex strings.
Hex strings, exactly.
Oh,
And
yeah,
so
yeah. No,
compression should pretty much eliminate the overhead of that.
Yeah.
But wait, but then we're gonna have to introduce the compression algorithm.
But that's what I'm saying. Like, I don't think this is worth it. I think like we're arguing over sort of gains that if we were to write
but don't like, I mean, can't you get the browser to compress it or something? I thought
we
like
can,
stuff
but then
like
we got to
that.
decide on standards, and everyone has to include this compression. Then what I'm trying to argue here is that like relative to
right.
the like what we already have for numbers for participation, whatever, these are like not limiting factors yet. So I agree if we're struggling to get all this done and we have gigabytes worth of files or whatever, but I mean, a 7 megabyte file I download, I don't think we're constrained yet.
Right, not in the average case. I'm just
Right.
wondering about the worst case, basically.
So I mean,
I agree. In the
other thing-
average case, it's trivial.
The other thing is that we like
How much time are we giving people to participate? Is it 5 minutes or?
I think Jeff can speak to that, but I like A, it's dynamic, but B, I think the ultimate time limit is something like 3 minutes.
Okay.
Wait, that's a lot of time, right?
Yeah, yeah.
I mean,
But
let's say it takes 1 minute to compute, so you would have 1 minute to download and upload. So that's like, well, actually, I guess it could be asymmetric. Like if it's asymmetric, say you could do 30 seconds to download and 1 minute 30 to upload. So something like.
I think the problem with sort of giving people a lot of time is that I can register like 10,000 GitHub accounts, and then now you've given me, let's say, 3 minutes. I can put myself in the queue and then just waste 30,000 minutes.
I mean, the time to initial check-in should be more limited than that. So at the very least, you have to start downloading the files.
Right, but each participant gets like some upper bound to do everything.
Yeah. No, sure. There is a key point called slow Lorentz attack, but like the sort of like do the minimum viable to keep the server happy. Agreed.
Wait, are we only requiring a GitHub account? No further. Have we decided on that?
You can do Ethereum.
Yeah,
I was thinking that we could have some rule like that. There's been a commit in the last month or something like that, and a repository that's more than 2 weeks old, something like along those lines.
Okay, I see. When did we decide on this GitHub? I wasn't aware of that.
This has been
GitHub
decided.
came into it. Yeah, well, it's not really. Yeah.
Like,
sorry, I didn't get that.
These are all discussions that are still happening, Dograd.
Okay, I see.
Like
because I thought we're doing something like ENS or Ethereum addresses. Or
that's also another option. We can get around to it in a moment.
Here's with GitHub accounts. Here's how you could do it. Make sure that it has a commit that is at least like, well, that was made before we made this decision, basically. Then it's very difficult to game because you would have already, and that still includes like a huge number of potential people. So it's I think that would be the way.
Jeff opened a PR 5 hours ago against the repo where he's put some of these ideas down, and I assume we're going to discuss that later on this call. But this is part of why we want to get on GitHub, so we can have these discussions sort of out in the open, because there are sort of many ideas. We've all been throwing rough numbers around, but we actually need to make some decisions on these constants. But I think it's all too much in the abstract now to going to complain. But some ideas like this are pretty reasonable.
Okay, so I mean, like basically with a 3 minutes, 7 megabytes file, I think I get like, you need probably like a 600 megabits upstream or something realistically to be able to complete this, giving 1.5 minutes for the upload. It's probably okay for most people with a broadband connection, but it's probably gonna fail for some people if they try to do it using a mobile connection.
Right.
I guess you could say that's fine. I mean, that's probably fine. And just tell people, hey, like, make sure that you have a good connection. Like either you go to a spot where you have like a good 4G connection, or you do it at home.
Wait, you're saying you need 600?
600 kilobit upstream.
Okay, yeah, okay.
Sorry, I said megabit before.
Yeah,
Right?
I was just
sorry,
like,
sorry.
whoa,
Yeah.
my numbers don't.
Yeah.
Yeah. Yeah.
Okay. So,
The other thing is, my part of what I proposed in the past is that at the end of all of this, we have a separate time where you can apply for longer slots, etc., etc. So if you fail to get into all of this because your internet connection was too slow, you could apply for one of those slots.
Yeah, but I really want to reserve those more for specials, like for Vitalik using PyECC and stuff like that, rather than making that a general thing for. Like I think you should get into these if you have a justification why your contribution adds a non-trivial amount of extra security.
Yep.
Wait, but then can't we say that we'd be sort of disallowing people who don't have strong internet connections, like maybe in countries that just don't have good internet?
Right. But is that nowadays, is that a concern that, like, I mean, how many countries can't you get at least 1 megabit internet connection in?
I don't know. I'm not
I
sure
don't know.
it's not a concern. Okay, yeah. Cool. Yeah, so okay, so we're keeping the JSON and the cryptography takes string text strings. Another thing was the mention of IRTF BLS draft in the specs. I think that some people just won't have read the draft and they might not know what actually it is. So in the implementation I did, I wrapped PyECC and just exposed methods like pairing, is in subgroup, is identity. So methods that don't actually relate to to the draft. So if you made your own BLS 12 implementation, it doesn't need to be compliant or even relate to the draft.
So the reason I included the draft is where we have all the like constants, etc., etc. It's also like what most of these libraries are talking about, but I don't think I say anywhere that it's required to be fully compliant. And that's why I have the file bls.md was to define all these endpoints.
Yeah, you didn't say it was compliant. Yeah, I didn't mean to say that. I just said that there was mention of it.
Yeah, but my mention was just like, this is the curve. Like, here is the document that defines the curve and defines what point compression is.
I think there was something on key validate, but I can double check.
I think I said, like, if you are using an implementation there, then you could use key validate as a way of doing some of these checks. I was just trying to offer another option, but like, absolutely, if any of this is unclear, I'm happy to make changes, accept PRs, but I'm not trying to enforce you need a full IRTF standards compliant implementation of BLS.
Yeah, oh yeah, sure. Yeah, it's just, maybe it's fine. I just thought it might be better if we just had something very general, like this is what you need from a pairings group, and that's it. But yeah, I guess actually if most libraries are IRTF compliant, we could have this extra section that says you can implement it using this or something along those lines.
Yeah, I mean the IRTF like really is just a fancy way of me pointing to the curve parameters. So if that's not clear or whatever, then that's also just my bad wording in the specs.
Might have been just me reading this incorrectly.
Yeah, but that the fact that that was possible to you is sort of an issue to me. But anyways, I think we're on the same page here.
I guess the next part, we said that the pairings checks, it had a should, so they should use the random linear combinations. I guess it will just be really slow if they don't.
Yeah, I'm not gonna like it's not wrong if you don't do that, just
Yeah.
it's ridiculous.
Yeah, I agree. Yeah.
Yeah.
I think that was mainly where the differences applied. The witness continuity check, I wasn't quite sure what it was doing, but maybe we can take that part offline. I think it's missing a pairings. A pairings check to check that sort of the previous ceremony continued from the current ceremony continued from the previous one by using the pairings check.
Yeah, so I think there's I was assuming some statefulness or something there.
Okay,
on the part of the coordinator. But yeah, if that's not clear, then that's just probably wordings, or maybe I've missed something. But yeah, sure, let's chat after this call.
Cool. Yeah, apart from that, I think that's where most of the differences were. I changed up some of the terminology. Like I don't use the word transcript anymore. I use SRS or update proof. But maybe we need, yeah, maybe this is getting into the weeds and we can discuss this offline, because I think that's mostly the things we've discussed are mostly where the differences in the Rust implementation are and the Python.
Yeah, sure. I don't know if you saw, I did a big change just before I went on holiday, which sort of changed what was called transcripts and what wasn't, etc. So the sort of change now is that the whole file is called the transcript. And then there's the notion of a sub-ceremony, which refers to like the individual collection of powers of tau plus witness.
Okay, yeah, that's actually a lot more clearer, since the transcript just defines the interaction between two parties.
Yeah, I managed to confuse myself once or twice, and I know you'd been confused in the past, and I was like, okay, cool, I'm clearly being an idiot with my naming schemes here. So I changed that. Yeah, so it's a bit different now.
Okay, yeah, that makes a lot of sense. Yeah, so I think that's mainly all of where all of the discrepancies are. While we're on the call, I'll just try to push this Python version and then modify it to just slightly to match the specs. I just need to modify the serialization from binary to JSON. And I think add this sub-ceremony API. Yeah.
Yep, that sounds great.
Yeah, so thanks.
So I think that covered the updates that Kev has or expects to do. Is that I'm assuming you're fine working on that on your own, and that'll be ready by the 15th or hopefully a little bit before.
Yeah, definitely.
Okay, great. There's also we had talked previously about this idea of a rationale document. Is that something that we can also make sure to have? It sounds like it would be helpful for the audit.
Yeah, I did add, I was trying to bake it into the Python reference implementation, but I'll pull it out and put it in a separate HackMD document. I need to modify some stuff now because we've sort of changed, like using compressed versus uncompressed. So yeah, I think it would be really helpful to sort of explain why we diverged from previous ceremonies as well.
Yeah, for sure. And the more context that we can give people, the better, I think. Is before we send it off or do the kickoff call, is there anyone that you'd like to have review it, or is the internal group here probably sufficient?
I think it's sufficient. What do you think, Colin?
Yeah, I'm happy that's sufficient. I mean, I haven't read I haven't read the stock up, so I mean, obviously I want to review it myself, but like
Yeah,
the
I'm just
decisions being
thinking,
made here aren't insane. So
right. Yeah, I'm just thinking about obviously a bad situation would be Kev finishes it like the day before and there's no time for other people to review it, but I don't think that's going to be the case. We just want to make sure that there's enough time for some other people to get eyes on it. All right, anything else on the implementation and prep for the audit? If not, Jeff, I'm assuming you have some stuff from the last 2 weeks that you've been working on. Do you want to give updates there?
Oh yeah. So I guess the big breakthrough is we have a solution for running the WASM in Firefox. It's
awesome.
Yeah, so at least we can do it in Firefox. It's not multi-threading the way it is in other browsers, but we've got time to work on that and get it multi-threaded, I think. But at least we got a solution. What else? Yeah, I've uploaded those specs to the KZG-Ceremony repo. There's a couple more to come through yet, but I promised to do those last time, so they're on the way. I think that's probably all I have to update about.
What's the single thread performance on Firefox?
Oh, the issue in Firefox is, so we had Rust compiled to WASM and running fine in Chrome with multiple threads, but it crashed in Firefox. And so we could run, it was the multiple threads that were causing that issue. So we could run a single threaded model in everything, in every browser. And effectively what we've done is keep the multiple threads in Chrome-based browsers and do a polyfill to run the single threaded version in Firefox.
Right. What I'm asking about is what is the performance right now? How long does it take to?
Yeah, so I haven't got good figures on that. So in Chrome, it was like 5 to 15 seconds in that sort of range. I think in Firefox, probably more like 40 to 50 seconds.
Okay, single threaded.
Yeah.
Cool. Okay, I mean that's still promising. What CPU is that?
Oh, that's like a laptop or something.
Right. Is it online yet? Is it on the trial website? Can I try it?
The Firefox version is not.
Okay.
The version that's currently online is the multi-threaded one that runs in Chrome.
Okay. I would be interested in trying that once it's ready.
Yeah.
yeah, me too. See if that interface is slightly nicer with Apple ARM as well.
Jeff, do you know
we
why
haven't
it's
we haven't
failing?
addressed that. But, oh, it's because of modules. When you compile it with Rayon, it insists on doing a modules build, and Firefox doesn't support web workers with modules.
Was you using Comlink?
No, unless it does behind under the hood, but I just use a WASM pack, which recognizes what WASM bindgen rayon, and insists on doing the modules thing.
Yeah, maybe we can look at that offline, because I remember getting Firefox to work, but it was Safari that just didn't support nested workers. That was the problem.
Okay. Yeah, I'll get in touch with you about that.
Sorry to backtrack. I just remembered I had another thing about the API. Can we allow a single person to make multiple updates? So a contributor can submit multiple update proofs.
You mean like participate multiple times?
Yeah.
No, we're explicitly banning that.
Yeah, I mean, you could with multiple identities, like an ENS/GitHub account or whatever, but
so maybe I should. So as the coordinator, whenever I receive a new SRS, there's only one update proof that comes with it.
What do you mean by update proof?
So an update proof proves that the SRS the coordinator currently has, and the new SRS, it was changed via some secret.
Yeah. So that's
yeah.
That's essentially my continuity of witness or whatever the hell I was calling it check.
Right. Yeah, I was asking because the API could easily allow multiple update proofs. I think Marius brought it up before. It didn't bring any security advantages, I think. And actually never mind, because that introduces a lot more complexity. Because if I do a sub ceremony, I'm gonna have to have a bigger upper bound than 3 minutes. So I could easily DOS the system.
I'm still not following what you mean by yeah, multiple.
So I guess the scenario is that I'm a contributor, but then I'm doing a ceremony, a sub ceremony of 10 people.
Oh,
So,
like that. Yeah, but
yeah.
then just get all 10 people to
Exactly.
enroll separately, or get them to contribute their randomness on your one machine if that's for some reason something you want to do.
Yeah, exactly. Yeah, I think it introduces a lot more complexity. I only ask because the API allows. Is someone's internet connection?
Yeah, I think it was Rod.
Yeah. Yeah, I only said it because I noticed the API easily allowed it, but actually it opens up a DOS vector because you have to increase the upper bound for this contributor because there's multiple people contributing.
Yeah.
Yeah.
I mean, if we want, we can enforce another check that the length of the continuity of witnesses or whatever they're called increases by 1 every time.
I think it should be fine to just have one update proof. If you look at the actors.py file, and then the coordinator, you'll see that if it's one update proof, there can only be one update from the previous to the current SRS. So it should be fine, I think.
Yeah, and is that stateful? Yeah, looks like it.
Yeah, so the coordinator only holds one SRS at a time. I guess he can send off the SRSs to some IPFS place, but he only ever needs to hold one SRS.
Yeah, so all the update proofs are kept forever in the transcript JSON.
And the transcript JSON is sent to each participant.
Yes.
I think that might be a bit that might be a lot of megabytes in the end. Because if 10,000 people have come before me, then I'd need the update proof from all 10,000 of them. Is that correct?
I mean, that's what it's currently defined like in the specs.
I think that might be more than 7 megabytes.
Yeah, I think we had this yeah, so like 10,000 people is gonna add how much should that be? I must double check, but I like in my head, I think it didn't get much over 15 megabytes for like 10,000 people.
Right. But as a coordinator, I only need to know
yes, agreed. But there's a separate like that ultimately to verify the transcript, you need to know everything. So now we need to store separate versions of like the abbreviated and unabbreviated transcript. For verification after the fact, right? Now you're sending an abbreviated transcript to participants. I mean, I'm happy to define this, but this is just something that.
Wait, so after the fact, all I need is all of the update proofs that are saved somewhere, and the starting SRS plus the final SRS.
Yes, and that's basically what this file is.
Right, but during the ceremony, I only need.
Yes, agreed. But that's what I'm saying. There's sort of like the difference between this now abbreviated and unabbreviated SRS, and I wasn't distinguishing between the two for simplicity.
Oh, I see.
If people think it's worth it, I'm happy to define a second object.
I'm a bit wary because having the file size grow with the number of participants. I think we said 10,000, but I'm not sure. Like usually we just, as a contributor, I don't care about the previous contributions. I only care about my one, so.
Yeah, but we need like some kind of intermediate outputs. And if you want to now attest to your contribution, that needs to be verified against something, which means we need to be somehow posting this full file elsewhere.
Right, but you can only fully attest to it after the fact, right? Like you can attest to contributing to some ceremony, but until the SRS is completed, that's the only time that you can attest to being a part of this ceremony that this SRS was created by.
I mean, you just point to your contribution in the what were you calling it? You point to your update proof.
Right. So I can point to my update proof, but I also need to link it to the final SRS.
I mean, you can do that by your update proof being a subset of the total. Like if your attestation is basically, this is what my update proof is, and that's all that matters.
No, I think you also need to prove that your update proof was a part of sort of the last SRS that gets done, because you can.
But that's done by incrementally checking the update proofs.
I think I understand what you mean, but to do that, you can only do it after the fact, right? Like there's no way.
But your update proof doesn't change between when you participated previously and at the end.
Right. So the attack vector, or what the coordinator can do, is you can take your update proof, or he can just basically create a different SRS.
But then your update proof doesn't appear in it.
Right. So you'd have to attest after the fact. You can't attest during the ceremony.
If I came,
it doesn't matter, right? We don't really need to attest during the ceremony. So I don't know.
Well,
I think this discussion seems.
I disagree a bit with that, because that's the time when people are already participating. Like it's going to be much harder to get people to come back after the fact and still like know what their participant, like where they were in this whole system. Like where.
Right. Okay, but I mean, the reasonable thing is during the what happens during the ceremony, I think you should just get a signed confirmation by the sequencer you have participated. And then if the sequencer is lying at the end, then you can like cry wolf and pull out the signed message, like he was signed, I participated, but my contribution isn't in there.
Right. I think it's important that people attest to both participating and that their contribution was a part of the final SRS.
I guess the distinction here is between saying I participated in the trusted ceremony and my proof is dead beef, and the I participated in trusted ceremony output this and my proof is dead beef.
But I mean, you can post your proof immediately after you have participated.
That's what I'm arguing for.
But it can only be verified when the ceremony is done. I think that's fine.
Right.
Yeah, sure.
Right.
And I guess it would be even better. It would be even better if like you actually got, I don't know if that has been thought. I mean, I don't want to cause complications, but I guess like ideally the sequencer would sign that you have participated as well, basically to like, yeah, increase trust in the sequencer, because at the end it can't have excluded some of the contributions. But yeah.
Right. So I guess to go back to where I just started, it was including these proofs during the ceremony.
I don't feel it adds anything. Like I think like they only need to be stored by the sequencer. It's just a database.
Place.
Yeah, in a public place, and like, look, I'm happy to do this. I just don't like the idea of having these separate definitions of these files. And like this public place in this essence then becomes a like distributed storage amongst all the participants that you can see all the people who participated before you. So like not only are you keeping the coordinator honest by having like checking it at the end, you're also doing it in the interim because you can verify other people who've already participated.
Right, but I don't think the interim adds much. I mean, we're gonna run the sequencer, like it's gonna be fine. We're gonna make sure that it's fine. I don't think it increases anything like that you can check it while it's happening.
I mean, sure, but
wait, so I think I'm in the middle of what
so
both of you are saying.
If it runs over 30 days, and let's assume that optimistically most people completed in 1 minute, then we could have 43,000 participations. So
yeah, like I agree with that statement, like, but
yeah.
We're not going to have 43,000 participants. I'd be ecstatic.
Maybe. Right.
We might.
Yeah, like goals.
Right.
As I said a few times, I want to have more participants than we have points in the ceremony, which would be awesome. But yeah.
Right. Okay. I mean, I don't know. If it causes technical complications, then I would say like whatever, like keep it as it is. But my intuition is that it seems that we should be able to remove the proofs from the participant files. I feel like, I mean, what's the participant gonna do with it? They don't do anything.
I mean, realistically,
like, they're not gonna check. They're gonna like exactly. So you can
to me, all it does is it saves the complexity of having like two different files. I'm happy to include that. Yeah. I just think it makes it more complicated for reading the spec, where there's now one version of the file that you can receive at one point and another version that you're going to receive at the end. And I'm fine with that. We can do that. I just think it's less pretty and less easy to understand.
So just file it.
I mean, it's basically just two different versions of the same file. Like one says like one is without proofs and one is with proofs.
Yeah.
Like it's just a modifier on the same file. Like the JSON can literally be the same, specification can be the same, And
Yeah,
in
but
one,
to
the
me, that
list is
almost
just
makes it
replaced
worse
by
because these are now almost identical things, except you need to understand
Mhm.
this tiny intricacy. And that's like my concern here.
Wait,
They
so
are there.
as a contributor, all I receive is the SRS file. When I'm doing it after the fact, I receive 2 SRS files and a bunch of update proofs.
No. Oh, it should just be the same, like one transcript file. The transcript contains everything.
Hmm.
At the end.
Yeah, I guess my only concern is that we say we might have just 10,000, but it's a bit weary that the proofs could be sort of an impact.
Yeah, I was having that conversation just last night and with someone. He said, "Oh, you're going to get 100,000 participants," and my initial reaction was, "No way!" But then he started to say, "Well, people think there's going to be some reward at the end or something. They'll just dive in." And
Okay.
if we end up with a 60 megabyte file, then we're kind of cutting off that possibility because you're going to end up with a 1 minute, 2 minute download.
Okay, it seems like I'm very clearly in the minority here. I will define a truncated and non-truncated version of this file, which basically does the list include all the proofs or just the first and last element in the proofs? I'm fine with that.
The first and last.
As in the last update proof.
So I don't think it needs any update proofs, right? Like if I'm contributing.
Sorry, this is like I think again just talking across terminology here, because
Okay,
I think
right,
the thing you define as update proof is slightly different. But basically, the thing that what did I call it?
Right.
The point, which is basically the generator multiplied by all the secret keys. Actually, don't need any of that because that's encoded in G1 and G2.
Right. Yeah, I think it's just the SRS, but we can take it offline just because there's terminology differences here.
Sure. Yeah, I mean, if we're starting with the generator, then then it's the same. But anyways, yeah, okay.
Yeah, I did see that in the transcript. We start with the
Yes.
So it's just a copy of the generator multiple times.
Yep.
Yeah. Okay. Yeah.
Okay, I'll throw together PR with these changes and hopefully it's clear enough.
All right. Cool.
We are at time, and I realized, Jeff, did we miss anything that you're working on or any updates that you wanted to give?
No, I think I've covered everything. No, I'm good.
Okay, great. Real quick, let's just restate what people are going to be doing. Obviously, the audit is main focus for the next week and a half. What else? There is somebody from PSC working on putting together a wireframe for the site. That's really exciting. And hopefully we'll have that sooner rather than later so we can start. Jeff, what would it take to get that wireframe or once there's a prototype, combine it with your existing site?
I'll have to see how much. Yeah, see how much integration. Oh, so you actually want like the test data to feed into that dashboard. Yeah, I don't know. It feels like a couple of weeks work. So it's like a few of these meetings away.
Okay, that's fine. Just to give me an idea of the ballpark timelines.
Yeah.
So yeah, that puts us in the beginning of September, and I feel like by mid-September we should be. When do people think we should? What date should we try to run initial contributions through this. Obviously, there's still another audit with Sigma Prime for the coordination bit, and we'll have more. It seems like there's still some work to like package that and figure out what they actually need to see. But at what point do you guys think we would actually be running initial contributions? End of September, beginning of October. I'm just recalling the previous discussions we had. Or would it only be after DEF CON?
No, I think I ideally at the start of or a little bit before DEF CON.
Right, yeah.
Right. So
Again-
Carl, I guess for to run initial contributions, the only thing that needs to be fixed is sort of the APIs and the formats that we're using.
Yeah, I mean that's pretty much been my argument. Like as long as we can standardize all of this, then that's fine. Like even if there are some slight bugs in the stuff running on top of it, as long as we can keep the coordinator up and running through all of that, it should be fine.
Right. Right. So even if there's bugs inside of an implementation, we can just ask people to contribute again, for example.
Yeah.
And then everything.
It's like that's also this is what part of why I'm happy of doing it before the audit, the SIGP audit, is for these reasons too. I mean, should they discover that there's a bug which leaks all the secrets or whatever, then absolutely, I think we should start again. But sort of as long as everything that comes out of that is reasonably sensible, then I'm happy with it. And in the timelines I've posted previously, I've talked about sort of a closed contribution, which is where I think like we can have contribution, but we're not just like throwing this out on Twitter asking anyone to contribute. It's more like, hey, we have this thing running. We think it's pretty good. Please participate, but like don't be surprised if it all fails or something. With no expectation of it actually failing, but just trust the community members who aren't going to like spread FUD based off of this or whatever.
Right.
And under the assumption that we're comfortable in the cryptography.
Yeah.
Okay, that makes sense to me. Anything else I'm missing? Does everyone feel like we're on a, oh, go ahead, Kev.
Yeah, maybe I think we missed one way optimistic contributions. I think Jeff put it in, Carl mentioned it in the issue, I think, that we haven't actually finalized whether we're doing it that way or not.
I'm still keen on this, and I defined the API in a way that it's compatible with this. Sorry, the SDK.
So are we going for it, or?
What does that mean, optimistic? Is that
So
Justin's scheme or what?
No. This idea I came up with, but basically you assume that the coordinator is giving you an honest set of points to contribute on, and you only verify after you've contributed.
Oh yeah.
So you only and then if you're not happy with it, then you just don't attest to it.
Yeah, right. I don't think you even need to verify it. Like it's like the final transcript will always be fully verifiable, right?
Right.
So the issue here is it's a subgroup check. So if there is a low order group which gets mixed in with the points the coordinator gives you, then you can be tricked to leaking a few bits of your security, which they can remove after the fact by brute forcing all the possible.
Okay.
So
I see. Oh, so you're postponing the subgroup checks basically.
Exactly. So you only do the subgroup check after you've uploaded the file. We're not skipping it. And the difference here is you just choose not to attest.
Or you can. Oh, I see.
Actually, I think we could skip it if the contributor, because the contributors also would say this was the degree 1 element of the SRS that I was given. So after the fact, if you check that none of those have low order, then you can sort of skip all verification checks until the end.
So you're saying you check?
Like the
No,
running.
but that's you're saying the yeah. Okay. You'd have to then post not just the continuity thing. Sorry, not just your pub key, but also the continuity.
You'd have to post the tau at that particular point.
Yeah.
Like the tau that the coordinator sent you.
Yeah, but this information is like not. Oh yeah, this is yeah. So this is my how do I call this? The running.
The running product.
Yeah.
Right.
But what like? Yeah, this was the thing that was going to be lying around the file size. Well, like if you just post your pub key, then to me that's a unique thing to check. Like now you need both the pub key and the running update. Like you need a store.
So I think you need the running product after the fact, which is when you can also do the checks themselves.
The coordinator needs the running update. You don't need the running update.
Yeah, the contributor doesn't need it, but if you're verifying it after the fact, you would need it.
Yes, yeah, but because we're now not giving the, like, how do we know the coordinator hasn't messed with that after the fact?
Right.
They can always subtract out the low order elements that they gave people.
I think they need to multiply it. I think they can't, but I'd have to double check. I think they changed.
I think
they can that because they're low order, basically.
Yeah, exactly.
I mean,
you just brute force the.
Yeah,
You
if
brute
they're low
force
enough
the order.
order. Yeah. So, like, if it's like a 30-bit or so.
It's sort of a trade-off because you want it to be.
What powers do we actually have in? Can we avoid the low order checks with the? I mean, usually there are tricks to avoid them, right? Where you just
Right.
Was that a possibility at all?
I think Circom does avoid them by just checking one of the elements, and then they do sort of they show that if one of the elements is not low order, then the rest of them aren't low order, don't have any low order.
But isn't there usually like you exponentiate by the cofactor or something?
But that would change the point.
Yeah.
So you wouldn't know if it was low order. It just changes it. It means the result isn't low order.
Exactly.
Yeah.
Right. So we can't really. That's not really applicable in the trusted setup.
Right.
That trick. I don't know. I'm just wondering, like, because I think you can usually do that for signatures and zero knowledge proofs and stuff.
Right. If it's
but I guess maybe because that's yeah, I see. Right. Okay.
Right.
But if we need the actual points, then it might.
Right. Exactly.
Oh, actually, maybe that's not true.
Hmm?
Okay. What if we just always multiply each secret with the cofactor? I mean, that's still a perfectly valid secret, right? Because the cofactor is coprime with our with the subgroup.
This does mean for verifying after the fact, you'd have to also do that.
Sure, but I mean, that's not expensive, right?
Well, it just means this is a thing we're going to carry on forever doing whenever we have this transcript.
Sure. I agree.
Which I'm sort of envisioning clients doing on startup or.
Wait, no, that's not true. No, it just becomes part of the secret. Like it, including your commitment, like your G to the S. That will also, like, your secret is literally defined as, like, take whatever your secret generation process is now, and at the end append a step where you multiply it by the cofactor.
Hmm.
I think that's valid. That's a perfectly valid secret. You're multiplying it by an invertible field element. That doesn't change anything. Right? It's still a completely, like if it before it was uniformly distributed, still uniformly distributed.
I'm a bit concerned about adding that because I've never seen it in any previous ceremony. Like it seems
Yeah.
fine.
Yeah, intuitively, I agree. It seems okay, but want to run this past some people first.
But yeah, I mean,
I guess you have to multiply without doing modulo afterwards. So the catch is, okay, here I realize what the catch is, because if you do modulo the subgroup, then it's not actually like inside the cofactor group. It wouldn't be. So basically your secret becomes larger than 256 bits. Your secret is now 381 bits. This is the downside. Okay, so it's yeah, okay, so, okay, no, sorry, this is a bad idea. Yeah. There would be a performance penalty of this. Would basically everything would be 50% slower. Subgroup checks might be cheaper. I don't know.
Right. I guess we can, because there's like 3 ways to do the subgroup check, right? Use the endomorphism, just do it the naive way by multiplying it by the curve order or the largest prime subgroup. And then doing it the circum way, which is just checking one element. The circum way would be the cheapest, but I guess we just need to write a proof that it's actually okay.
Well, but the circle, no, but that only works if you are actually checking the that it's a correct ceremony, but we aren't doing that either, I assume.
Yeah, you still need to then do a pairing check for each of the points.
Yeah, you would still have to do that, yeah.
Yeah, the pairings check is always there.
No, you don't do that. Participant doesn't do a pairing check.
Yeah.
The participant.
You can as a way of implementing the subgroup check, but there's
I think doesn't the participant do a structure check to make sure the SRS is increasing in by powers?
Nope.
1 power. Wait, they don't do that?
No, not on the specs.
Oh, okay, mate, that's another difference. Because shouldn't they do that? I thought that was quite important for them to make sure the SRS has the right structure if they're verifying it.
I mean, they should do this after the fact, yes.
Yeah. Well,
like we need to check this for the final transcript. But if you trust the coordinator,
yeah, I agree with Carl here. That's the right way to do it at the end. Participants don't need to do this.
Yeah.
Yeah.
Huh.
So I mean, in theory, there's a way to do the subgroup checks relatively cheaply, right? If you do a random multi-exponentiation of the whole string, then you can just do
plus 1 subgroup check.
Exactly.
Yeah.
And so you can reduce the multi-exponentiation because you can do it using local randomness, so you can do it statistically. So like 30 bits might be enough. But I mean, someone needs to implement multi-exponentiations. I don't know if, or do we have already? Do we have that ready in our libraries?
That's not there.
Yeah, so that's probably technically a bit annoying. Like theoretically, you could do it very fast, I think, but
yeah, but
practically,
this is, I mean, basically just a slight optimization over the SOCOM version Kev was talking about. It's all the same thing. We're not gaining.
Yeah.
Right.
Well, it would be quite fast overall. Like, I mean, theoretically, if you do a 30-bit multi-X over 16,000 elements, then like that is, I don't know, like
is that faster than the endomorphism?
I don't know.
Yeah.
Sorry, what's the endomorphism subgroup check?
So I don't know how
Oh,
that
I
works
see,
under the
okay.
hood, but it's the way that most
Okay.
libraries do it these days. So I think the Zcash people came up with.
Okay, I see. Right, maybe, yeah. Yeah, I guess it depends whether it's cheaper than an addition.
Yeah.
I think you can do it at the cost of a few additions per element, but maybe the endomorphism check is already on the order of one addition, then you don't save anything.
Yeah.
So I just need to write this down. So contributors only do a subgroup check.
Yeah.
Okay. Let me recheck the Rust code, because if we was doing a pairings check, that would mean the code is a lot faster. If we was doing
Yeah.
the verification, so contributors.
Like my other thing is I'm trying to not make a requirement that people have to implement pairings for the BLS. Like you just need curve ops if you're writing your own implementation.
Yeah, I think that's good, yeah.
Yeah.
Right.
To be fair though, we could like the subgroup checks, we could make them optional, right? I mean, you can
But they're already
perfectly
optional. They're already optional.
Right, exactly. But like basically, if someone wants to run PyECC, then they just skip the subgroup checks.
Yeah.
Right.
Or do an MSM style plus one pairing.
Well, I don't know if you can still skip the subgroup checks from what Carl said, because the contributor could just minus the
Yeah, that's your trust assumption.
Does the sequencer, sorry, yeah, does the coordinator sign? So are the coordinator messages signed?
No, currently not.
Right, because that would also be a way to avoid the subgroup check. If the coordinator signs all messages to participants, then participants could later prove that a coordinator has sent them a message with a like element that's not in the subgroup, and that would obviously invalidate the whole ceremony. And then you don't really need to do subgroup checks immediately. You can do them at your convenience and say like, oh, I got a / that coordinator.
So the only thing is then this requires us to have a signature library built into the participant.
The coordinator, right? I mean,
I don't care about complexity in the coordinator. I only care about complexity in the participant. You need to verify the signatures.
Or you can simply use SSL, like simply trust that the browser, like you do everything over SSL, you certify everything.
I mean, that's
essentially.
I mean, like you do already have like an encrypted connection for downloading this, but like that's sort of a separate layer of the stack, right? There's a difference between downloading something with SSL and then needing a full, like being able to verify things against a certificate after the fact. Like that's.
Do browsers store like the signatures when they download stuff over SSL, or is there some way to get this via JavaScript or something, like to get the actual signature? I don't know that.
I don't know, but then to me, this is just like accentuated by people not running in browsers. Like even if this was the case, if you're writing a CLI implementation. Like
to be fair, I actually expect that is easier. Like I think with curl or wget, I think you can probably quite easily get the signature. I would reckon. I would bet that's easier than in a browser.
Possibly. I don't know. This is added complexity. I'm not sure it's adding much. And now we also need a mechanism for like a testing against the participant or whatever.
Right.
I think the idea of just like you not attesting to your participation if it goes bad, I think is better.
So I'm not sure. Like I don't know. Yeah.
Okay, so I guess we can say,
Again, this comes down to the trust model. This will never come up.
Yeah.
The coordinator is never going to do this. So there's never going to be a reason for people to make this happen.
Right. I guess the point is also we want to be able to claim that this didn't happen. And then if someone said, hey, here is my file with a subgroup, with the subgroup check, with like invalid subgroup, then we want to be able to ask them, hey, yeah, can you prove that it was us? Can you prove that it was the sequencer?
Right. Yeah, that's fair. I also think that our trust assumption might not be fully justified, because I heard that the coordinators might be other people than the EF.
Yeah, but they're still going to be trusted members of the community.
Right. But can we?
I mean, the other risk is it might get hacked, right?
Exactly.
I mean, that's like,
Yeah.
I mean.
But I mean, if like,
like the
I mean,
whole
sure.
point of a coordinator is that you really don't have to trust it.
But
And
you still
it
don't have
will
to trust
actually-
it. It's just what happens in the case when you don't trust it. Do you have certificates to prove it's not worth trusting, or do you just have
Yeah.
people you trust on Twitter shouting about it?
Yeah, right. Right, I
And-
agree.
And like now,
The-
there's now
I-
key management and all sorts of stuff we're building into the coordinator.
Yeah,
Hmm.
yeah, I see. No, I mean,
And-
I understand the difficulty here. I'm just thinking what the. I think it can practically be complex, because practically the line where you trust someone on Twitter and you don't is maybe not 100%. But
Hmm.
yeah.
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 Mm. Okay, so I guess to summarize, we're going to do optimistic contributions, and after the fact, the user can choose to perform a subgroup check, or should we
I
say
mean,
they
should. You should still do it.
Right, so should instead of may perform a subgroup check.
Yeah.
And if a user tries to say that the coordinator sent them a faulty, a low order point, we just can't do anything about that. We just have to see if the user's trusted and
Yeah.
Okay, yeah, that makes sense.
I mean, this is also compounded by the fact that, to my knowledge, we don't know any low order subgroups for BLS.
Can probably, yeah, I should probably check up on that. I think I was meant to do that. I'm not sure, but I don't think it's a prime order group. But I could be wrong there.
Okay. I mean,
So I was disconnected just now. What's the question?
I'm saying, to my knowledge, we don't know any low order BLS subgroups. And then,
I mean,
Fair
you can
point.
very quickly check that, right? I mean, the prime is small enough that you can back that for sure.
yeah,
Sorry, the
This-
number.
yeah.
Hmm.
We should be able to quickly check that. Is the question whether you can even attack it using the subgroup?
Right.
Yeah.
What's the right? I guess there's no collision attack here, right? So it's really no, actually, I'm not sure. Yeah, no, I think it's a bit dodgy, because it would still have at most like 64 bits of security or something. So it's in this range where you're like,
It's possible.
yeah.
I'm not saying it's a trust assumption we should rely on. I'm just saying There's
Right.
just many things stacked against this that I don't think you could make a reasonable claim that this is not trustworthy, but like we can add this whole signature thing. I'm not hugely against it.
Right. So I guess we'll just be opening up ourselves to the possibility of a trusted person basically saying that the coordinator is malicious, and the repercussions of that is that basically all of the contributions that were taken in by that coordinator would need to be thrown away, I guess.
Well, I mean, you can't, like, you're not throwing them away. They're not useless.
Right, but this person who's trustworthy is saying that the coordinator's been malicious, so we don't really know.
Yeah, you just mark, like, assuming you trust this person, then you just mark, say, I don't know, a third or however many that coordinator was involved in points as being useless. I mean, you don't actually know how many bits of security were leaked because it depends on sort of what the subgroup is.
Right.
But even if you assume the worst case and that adds no security, you should still have lots of other points. But I mean, if people are worried about this, we can add a signature.
It has lots. It's quite smooth. It's 3 times 11 squared times 10,177 squared times a 6-digit number squared times a 7-digit number squared, 8-digit number squared. So yeah,
Okay,
you can definitely get information from it.
Yeah, earlier statements retracted.
But I'll just write this down because I think this could be some way for someone reputable to possibly just invalidate coordinators, the contributions made by a coordinator.
Yeah.
But you're saying that the way that we sort of mitigate this is, let's say Dankred is a coordinator and Trent is a coordinator. If Vitalik says Dankred's been malicious, then I'll just disregard the stuff that the contributions by
Wait,
Dankred.
there's only one coordinator.
No, we're passing it around.
No, yeah.
Oh, I see. Interesting.
Yeah, not actively, but there'll be like 3 coordinators over the period, kind of thing.
Oh, is that really necessary?
Yeah, because it's an anti-censorship argument. I don't think like realistically, it's not going to add much, but it adds something.
Well, I think it's also good for this because if someone reputable says that this coordinator has been malicious, then yeah.
Look, I mean, if we want to add it, we could, like, let's see. We could just add this as we could do this where the coordinator is identified by BLS signature, because we already have BLS in there.
Right. I mean, I guess we could just make it optional, right? Because it seems something that can be done out of band.
Yeah. So then we stick with optimistic. And then in the case that it goes wrong, you would have a fraud proof.
Right.
Well, you wouldn't. Why would you have a fraud proof?
Well, you can do I'm saying optimistic, but with the signature.
Oh, I see. We're adding the signature. Okay.
I'm saying I'm running through an idea here. Yeah.
Right. Okay.
By adding a sort of what are you imposing extra work wise, and then so you run this, and then you can do your own subgroup check, and you can do it the like very slow multiplication way or whatever if you wrote your own library, and then if that fails, then you can go and call on you can implement pairings or whatever to verify that BLS signature or something. I don't know.
Right. So the coordinator always sends a signature of the thing he's sending, and the contributor doesn't need to implement the BLS stuff. He could just ignore it if he wants to. Is that?
Yeah. That's sort of my argument. And then we're not adding too much more in terms of requirements because most people will have some kind of BLS verification in there.
Right. If it's a may and not a should, then I think it's fine.
Yeah.
Okay. Yeah. Thank you.
Yeah, it does mean this is a separate sort of object that gets passed around, but that's fine.
Yeah. I guess it's just a blob of, it doesn't really matter.
I mean, we say, I'm always scared of saying those words, like, sure, I agree with that. But again, like, we still need to define encodings and like,
Yeah, yeah. that's
technically
true.
it's true, but that still needs to be specified and then implemented.
Yeah.
Yeah. I mean, I was saying I'm going to differentiate between the like intermediate participation transcripts and the final output. I mean, I could bake this further into the intermediate participation things such that there's, and I can make that as a part of the distinction between these two file types.
Right. Yeah. Yeah, I guess it's getting a lot more complex in practice than we wanted it to be.
Yeah.
But, okay, yeah, I'll just write down what you guys just sign down. Then I'll change the spec. Yeah.
I guess just quickly asking Jeff, is this something we've seen in past ceremonies that like you get a certificate that you can have a fraud proof against the coordinator for?
Yes.
Okay.
Yeah. Yeah.
But I think in past ceremonies, they did different types of like signature schemes, which is a bit complicated. I saw some doing GPG and stuff like this.
Yeah.
But, okay, cool. Written it down. Yeah, so I think that's about it. Yeah, sorry for the sort of long. I think Trent was talking about next steps, was it?
Yeah,
35 minutes ago.
Yeah, we diverged quite a bit from that closing comments, but that's okay. Yeah, I mean, yeah, I'm more than happy to stick around to hear discussion, but it does remind me that we should try to have these more discussions in the public channels, which I'm assuming some of this is happening in private, but just so there's context for anybody who's catching up in the future, or just context for design decisions. Obviously, we have this recording, but ideally it'd be happening in the public channel. We don't have to get into it now, but I'm just remembering that there was this discussion around like bonding ETH or something. Is this just a concept or something that people are interested in considering for this project? I think I saw Kev respond in there.
Oh, all right. Sorry. The person was mentioning that basically like people in Ethereum can bond ETH like a conviction to say that the ceremony was good.
Right, yeah.
If somebody has basically obtained tau, then they can withdraw the ETH from whatever the contract that the bonded ETH is in. I think they rephrased it to be something like a bug bounty. In that context, I think it sounds good. Like if you found something wrong with the trusted ceremony after the fact, I think it'd be reasonable to sort of pay you something if this could lead to the tau being exposed in some meaningful way. I'm still not quite on board with the bonded ETH situation. I think it introduces a bit more complexity than we'd need, but the bug bounty seems reasonable.
It's completely independent, right? I mean, anyone could design such a smart contract. So
Got it.
Yeah, it'd not be directly related to sort of the trusted ceremony.
but that doesn't matter. Like, I mean, anyone can just, like, once we have Tau, someone can just deploy a smart contract that that allows the payout of a bounty if you send a proof that you have found Tau.
Yeah, okay, yeah, sure. If it's not related to the trusted ceremony in any way and we don't sort of need to do anything, then I think it's fine. If it's like out of
We can
bounds.
just have it out there as a suggestion. Someone might do it, and you can easily just, anyone can just put Ether into that contract.
Yeah.
Okay.
Like, it seems super simple.
Agreed. We can do it in a, like, have someone do it independently. I don't think we'll see it because there's just like, what's your ROI on this?
Right.
Yeah, I don't think we should do it. I don't think we should
Yeah.
complicate things with something
Yeah.
like that. But I think, like, putting it out there for someone, hey, here's a cool little project. I think,
Yeah. I mean, I
Right.
think just having some people publicly commit to a bug bounty is a far more meaningful and effective use of capital. But yeah, sure.
you mean rather than putting it into a contract?
Yeah.
I don't know. I mean, people seem to have really enjoyed the little bounties that we put on our cryptography problems. So I'm not sure. Like, I've always had good.
I mean, possibly,
feedback on
but given the value of the secret, like, to me, the amount you need to retrieve has to be very, very large.
Right.
And then I just, like, the capital inefficiency of having that all locked up in a smart contract seems insane to me, but I could be wrong on this.
Fair enough. Fair enough. I mean, that is an argument. Yeah.
Yeah, it's like I just don't see this being meaningful, but I, again, could be very wrong.
Right.
Okay, so we can. We don't have to plan to include that in this ceremony, but somebody could do it if they wanted.
Yep.
Cool thing about a smart contract is that it can be claimed anonymously. Like that, someone like an Amazon sysadmin who managed to, like, get the secret by breaking, I don't know, the coordinator could.
Yeah.
Yeah, I guess my argument there was that I could just break Ethereum first, withdraw money, and then go to the contract and then just withdraw more money. Like, you need to coordinate between the contract and the protocol.
Right, I see what you mean. Fair enough. Okay, maybe the contract is more interesting in the interim time between it being implemented on Ethereum or it being used extensively. Sorry, before that happens, basically. It could be interesting to have that out there. But yeah, I guess, yeah.
The time between we done with the ceremony and the launch of 4844.
Yeah, right.
Yeah, so
I agree that's hopefully short.
Yeah, exactly. And I'd like to keep running this for as long as possible.
On the other hand, there might still be several months until it is seriously used. Like, the actual money you could get out of it in the first few months might be very, very low.
It's up to L2.
But yeah, I mean, I agree. Yeah.
All right, now we're definitely diverging into
Okay.
before adoption. Okay, so yeah, we should probably wrap up the call now. Is there any final comments? I think everybody is aware of what is going on and what they need to do. Yeah, anything else before we conclude? Okay. Thank you, everybody, for showing up and having discussions. Excited to get this into the audit finally, and probably a couple weeks after that, we'll start to see the first interface, some of the little wireframes and stuff. So yeah, exciting progress. And yeah, like I said, let's try to put more discussion in the public channels if we can. All right. Thanks, everyone.
Thanks, everyone. See you guys.
Bye.
Thanks all.
Thank you. Bye.